Okay, good day. I've decided to have a review of everything you have in Chapter 1. So after you watch the modules and the exercises, the DVDs and the videos, then you can come to this one and look at the summary of what you have learned in Chapter 1. I should mention that when I did the videos, the modules, and the exercises, the book was on the older edition. It was the 4th edition. Now that we have gone to the 5th edition, the order of the exercises on some of them are different. So, for example, if it says I'm doing exercise number 74, in the new edition might be number 78 or some other number. So please pay attention to that and make the adjustment as we go. Okay, now first thing, the chapter starts talking about real numbers. Real numbers. It divides the real numbers into rational and irrational numbers. Okay? Under the rational number, it goes from the smallest subset, which would be natural numbers such as 1, 2, 3, 4, 5, all the way to infinity. Then whole numbers, which include 0, and then 1, 2, 3, 4, 5. So whole number includes the natural number plus a 0. Then it talks about integers. Integers are the negative whole numbers also, like -5, -10, -5,000, and then 0, 1, 2, all the way to infinity. So minus infinity to plus infinity, all the whole number without the decimal. Then it would get to, after integer, it would get to rational numbers. Rational numbers are the numbers which would include the whole numbers, the integers, and also the fractions. If the fractions are terminate in decimal, it would be a rational number. If it is a repeat in decimal, it would also be a rational number. For example, 1/3 is equal to 0.333, and it repeats. So this would be a rational number. Okay? Irrational numbers are the numbers that have non-repeating digits after the decimal. So for example, the value of pi, which is equal to 3.14, and then the number continues. I don't know, 20,000, or it just continues in the digit, and so that would be irrational number. The total of all rational number and irrational numbers are called real numbers. So that is one issue. Then in the chapter also they talk about how to factor an expression, a polynomial expression. Again, a polynomial expression the polynomial expression is a mathematical expression such as x to the third plus 3x squared minus 18, for example. This is a mathematical expression, or a polynomial of the third degree. The highest degree would be what the polynomial refers to. So in factoring a polynomial, there are some special product rule that the book talks about. So I'm going to write these one more time. One, it says if you have a plus b to the second power, this can be written as a squared plus 2ab plus b squared. Okay? Now, a and b can be real numbers, and it can also be a variable such as x and y. So you can use that interchangeably. Okay. So for example, if I have 3x plus 2y squared, then this one can be written as a squared. In this case, this is your a and this is your b. So a squared would be 9x squared plus 2 times a times b. That would be 2 times 3x, that is 6x times 2y. That would make it 12xy. And finally, b squared, it would be 2y squared, which is 4y to the second power. So again, I want to emphasize that a and b can be real number, or it can be expression. Another special product rule was a minus b squared, and in that case it would be a squared minus 2ab plus b squared. So the difference between this one and the first one is the sign here is positive and here the sign is negative. Another special product is when you have the difference of two squares, a squared minus b squared, that would be equal to a minus b multiplied by a plus b. Another one, if you have a cube, the difference of two cubes, a to the third minus b to the third, that can also be factored as two parentheses. One would be a minus b divided by multiplied by a squared plus ab plus b squared. So if I multiply these two parentheses together, this one and this one, I would get a to the third minus b to the third. If I have the summation of two cubes, a to the third plus b to the third, that would be equal to a plus b times a squared minus ab plus b squared. Okay, we use these special product rule to factor a polynomial, and also to simplify a polynomial further, whether it is in the form of rational expression or not. We can simplify it, and there are so many examples in your book and the examples I have done and on the DVDs and the videos, and you can refer to that. Another topic here talked about exponents. Again, exponents is when you have x to the n power. That is an exponent. X is called the base. This is the base, and n is called the exponent. Right? So properties of exponent. Is something you would use again to simplify a polynomial or a real number. So you need to know all this different properties. The first one, it says if you have a to the m power multiplied by a to the n power, that would be equal to a to the m plus n. So when they are multiplication and the bases are the same, you just add up the two powers. If you have a division, so you have a to the m divided by a to the n, then you write one base and you subtract the power, numerator going first. You subtract the power from each other. Also, if you have a to the m, the whole thing to the n power, that would be equal to a, and now you multiply the powers m times n. Another property, if you have a times b to the n power, you can separate these as a to the n power, a to the n power multiplied by b to the n power. Also, if you had a division, which is a divided by b to the n power, you can have that separated as a to the n divided by b to the n. Again, these two, you can only do this when you have multiplication and division. If here, instead of multiplication, it was plus or minus, you could not separate them, okay, under their own power. Another set of properties, it has to do with property of roots. Property of roots, such as square roots or cube roots of an expression or a real number. The first property says if you have the nth root of a, and that is to the power of n, then that would be equal to a. So the same index as the power, would be equal to a. If you have nth root of two terms multiplied by each other, a and b, then you can separate these, same way you did it with the exponent, you can separate these as nth root of a multiplied by nth root of b. Also, if you had the nth root of a divided by b, the whole thing under the root sign, you can separate those as the nth root of a divided by nth root of b. One more. If you have a double root, for example, the mth root of the nth root of a, then you can combine the two roots under one. The index now would be the multiplication of m times n of a. Okay? While we are talking about the root sign, you of course remember that if you have the nth root of some x value, that would mean it is x to the 1 over n power, right? So we can write the root in the form of an exponent also. So basically all the property of exponent would be shared with the properties of the root. So keep that in the back of your mind. And finally, one other thing at the end of toward the end of this chapter is talking about the quadratic equations. Quadratic equations is when you have a quadratic expression such as a x squared plus bx plus c, set that equal to 0. This would now be a quadratic equation. There are three different ways you talk about solving the quadratic equation, one of which is to complete the square. Another one is using the quadratic formula. For example, the quadratic formula is probably the easiest way, and it can always be applied. That is, x would be equal to minus b plus or minus square root of b squared minus 4 times a times c divided by 2a. Okay? And again, a, b, and c in this formula are referring to this a, b, and c in your quadratic equation, which are real numbers. Those a, b, and c are real numbers. So that's how you solve for a quadratic formula. What I like to do now is go to the end of the chapter, end of chapter 1, and pick some of the problems, some of the exercises at the end of chapter 1. Let me see what page we are starting with. Review exercises on page 63 in the 5th edition. Again, page number might be different if you have earlier edition, and hopefully the ebook would have the same number. Now, it says from each section I'm gonna pick a problem and do it, a problem or two. It says the first set, it says classify the number as to type, and number two, it has a square root of 13. Square root of 13. So it is asking you, what is the square root of 13? And in that, you want to see whether it is a natural number, a whole number, an integer, rational number, irrational number, real number. Okay? So it can be bunches of things. The first thing, any number you have would be a real number. So that is 1. This is a real number. Definitely, any number you have would be a real number. Now, second question is this a whole number? Of course not. It has a fraction, right? It's not a natural number. It's not a whole number. It is not an integer. Then the next question is it a rational number or it is an irrational number? Well, if you use your calculator and take the square root of 13 and write it as a decimal, you would get 3 point something, and it will continue. In other words, it is not a repeating digit after the decimal, and it is not a terminating one. Therefore, this would be an irrational number. Okay, another one. Just let's say number 4. It says 0. What is 0? Okay, well, 0 is a number, therefore it is a real number. Now, is 0 a natural number, the smallest subset of numbers? The answer is no. Natural numbers start from 1 and it goes toward infinity. Whole number, however, it does include 0. So it is a whole number. Another set that includes 0 is integers. Integers are real number. And also one more thing, 0, it doesn't have any non-repeating decimal after it. Therefore, 0 is also a rational number. So 0 would have four different characteristics as far as the numbers are concerned. Okay, so that's that set of exercise dealing with basically section 1.1. Here is another problem, problem number 12. Problem number 12, it has 3 times 2 to the minus 3 times 4 times 3 to the 5th divided by 2 times 9 to the 3rd. The problem says evaluate the expression. So we want to evaluate this expression, right? Combine the like terms using the exponent, the properties of exponent we have learned. Okay, so let's have a long line. First, well, since everything is multiplied by each other, you have multiplication here, and here is also multiplication, here is multiplication, here is multiplication, or you have division. Then I can have these written separately. So I have 3 first, then 2 to the minus 3 times 2 to the minus 3. Now here, instead of 4, I'm going to write it as 2 to the 2nd and multiplied by 3 to the 5th. Then in the denominator, I have 2 multiplied by, instead of 9, I'm going to write this as 3 to the 2nd to the 3rd. Now, 2 to the minus 3 multiplied by 2 to the 2nd, I can write 1 base 2 and add up the power. Minus 3 plus 2 is minus 1. Then 3 to the 1 power multiplied by 3 to the 5 power, I write 1 base and add up the power. 1 and 5 is 6. Denominator, I have 2 to the 1. Multiply here, 3 to the 2nd to the 3rd would be 3 to the 6th. Therefore equal to. Now I have 3 to the 6th in the numerator, 3 to the 6th in the denominator. They would cancel each other. And in the numerator, I have 2 to the minus 1. And we have learned that we can write this with the positive power if we bring it to the denominator. So I already have 1, 2 down here. Then I'm going to bring this one from up to down to the denominator, and that would be also a 2 to the 1. I don't need to write the 1. The numerator, therefore, I only have 1 left. Therefore, this would be 1 divided by 4. So that this whole expression you have, here is actually equal to 1/4. Let's continue and do some other expression to simplify. Now, instead of having real numbers, we're going to have a and b and x's and y's. So let's move on to problem 20. Problem number 20. Change the color. Problem number 20. It is minus 3a squared b to the 3rd, the whole thing, to the 2nd power, times 2a to the minus 1, b to the minus 2, the whole thing to the minus 1 power. Okay. Understanding the properties of exponent, I will continue here. I can take this as minus 3, so minus 3 to the second power, so I can, since it is multiplication, every place is multiplication, I can have them separately. So I'm going to say minus 3 to the second power, to this power here. And then I have a to the second power, this a to the second power itself to the second power, b to the third power to the second power, the next 2 to the 1 power to the minus 1 power, a to the minus 1 to the minus 1 power, b to the minus 2 to the minus 1 power. So individually, we're going to raise these two powers. So first minus 3, this minus 3 to the second power, it would be 9. Then a to the second, that would be a to the fourth. B to the third to the second, that would be b to the sixth. 2 to the minus 1. 2 to the minus 1 would actually be multiplied. It would be actually 1/2. Since the power is negative, I bring it down to below. Then multiplied by a to the minus 1 to the minus 1, it would be a to the minus 1 times minus 1 is 1, so it would be a. And then b minus 2 times 1 is 2. Now, the only thing in the denominator I have is this 2. Since it's multiplication, that 2 goes for all of them. In the numerator, you have 9. I have here a to the fourth times a to the 1, so that would be a to the fifth. I have b to the sixth times b to the second, that would be b to the eighth. So that would be your final answer. 9a to the fifth, b to the eighth divided by 2. That would be your final answer for this problem. Let's look at another one, a little bit more complicated than this one. This is problem number 22. Again, all of these are in the review section in your book. Review exercises, if you have the book, it would be page 63, 64, 65. So 22, there is parentheses, minus x to the 1/2, y to the 2/3, divided by x to the 1/3, y to the 3/4. The whole thing to the power of 6. Equal. First, this negative here, you can look at it as a -1, and if it is -1 times h to the 1 times this, to the even power would be positive. So I really don't need to put this negative anymore once I raise everything to the 6th power. So first in the numerator, I would basically have x to the 1/2 to the 6th power, y to the 2/3 to the 6th power, h to the 1/3 to the 6th power, and y to the 3/4 to the 6th power. So we start h to the 1/2 to the 6th power. You write the h, you multiply 1/2 by 6. 1/2 multiplied by 6 is 3. Y to the 2/3 times 6. Y 2/3 times 6 is 12/3, which is 4. In the denominator, I have h to the 1/3 to 6, so it would be x 1/3 times 6 is 6/3, which is 2. And y to the 3/4 times 6, 3/4 times 6 is 18/4, which is 9/2. So it would be y to the 9/2. Okay. H to the 3rd divided by h to the 2nd. I actually can bring everything on top and write this as h to the 3rd times h to the 2nd. Since I'm bringing this up, the sign would change. So h to the -2. Then I have y to the 4th times y to the, since I'm bringing this up, again, I'm getting rid of the quotient, bring it up, it would be -9/2. So now h to the 3rd times h to the 3 times h to the -2, you write 1h and add up the power. 3 plus -2 would be 1. So that would be h. And y would be y to the 4th minus 9. 4 minus 9/2 is what? Is -1/2. Therefore, this can be written as h divided by y to the 1/2. Now, if you like, you can put that in terms of square root, or actually technically you have to rationalize the denominator, because when you talked about simplifying with the radical, one of them says that you cannot have a radical in the denominator, and here y to the 1/2 here is the square root of y. So how do you rationalize the denominator here? You multiply both numerator and denominator by y to the 1/2 and y to the 1/2. So it would be equal to the numerator, x times y to the 1/2. It would be x. Again, instead of y to the 1/2, you write square root of y. And denominator y to the 1/2 times y to the 1/2, you write the y and add up the 1/2 and 1/2. 1/2 plus 1/2 would be equal to 1. Therefore, this would be the correct answer for you. Okay. So this rationalizing denominator for when you are simplifying radical is important, because if you have a radical in the denominator, you have not simplified far enough. Another problem, problem 28. 28. It says 6x divided by 2 times 3x squared plus 2 plus 1 over 4 times h plus 2 equal. Now here you have two rational expressions added to each other. The denominators are different, so you have to take the least common denominator between these two. Between these two denominators, this one and this one. First, with the constant outside, between 2 and 4, the least common would be 4. Then, between 3h squared plus 2 and h plus 2, there is nothing really in common, so you have to write it as is. 3h squared plus 2 multiplied by h plus 2. Now this is the common denominator between the two. What you do is you divide this common denominator by the first denominator and the result multiplied by the numerator. So the numerator, I already have 6h. So that 6h needs to be multiplied by, when you divide this common denominator by the first denominator, it would give you 2h plus 2. So 2 times h plus 2 plus this plus. Then this common denominator divided by the first one, it will give you 3h squared plus 2 multiplied by 1. It is 3h squared plus 2. Equal. Now when I multiply everything together, by the way, here inside the parentheses, 2 times h plus 2, it would be 2h plus 4. So you multiply 6h by this parenthesis, it would be 12h squared plus 24h. That take care of this part. And then plus 3h squared plus 2. The denominator, you really have to just leave it like that. You cannot do much. Let's not fool around with it because you cannot cancel anything in this situation. So 4 times 3h squared plus 2 times h plus 2. The numerator, you should be able to simplify it a little bit. You have 12h squared plus 3h squared. That is 15h squared. You have 24h. And you have a 2. Denominator the same. 4 times 3h squared plus 2 times h plus 2. So that is basically your answer. All right, let's do another one. Problem number 30. Minus 2h square root of h plus 1 plus 4 square root of h plus 1 equal to solve this, you give a denominator of 1 to the next one. Now you can take the common denominator between the two expressions. Between square root of h plus 1 and 1, the least common denominator is the square root of h plus 1. That the square root of h plus 1 divided by the first one would be 1. 1 multiplied by minus 2h is minus 2h. Plus. Then you have 4 square root of h plus 1 here already. then this common denominator divided by 1 would be a square root of h plus 1. Therefore, this would have to be multiplied by square root of h plus 1 again. Equal the common denominator, write it again, h plus 1 minus 2h in the numerator. Now here, when you multiply this by this, we had in the properties, you had the square root of 5 times the square root of 5, right? Which is like 5 to the 1/2 times 5 to the 1/2, it would be equal to 5. So here, it would be just h plus 1. So it would be plus 4 times h plus 1. So minus 2h plus 4h plus 4 divided by square root of h plus 1. The numerator minus 2h plus 4h is 2h plus 4 divided by square root of h plus 1. That is the final answer. Okay, let's look at another one. Problem 32. It says 2v to the third w plus 2v w to the third plus 2u squared v w. Okay, and it's asking you to factor the expression. So you look at these three pieces and you see what is the common factor. The first one, you see 2 is in common, right? So 2 can be factored. All of them have at least a v to the 1 power, so it would be v. All of them has a w to the 1 at least, so it would be w. That can be factored out. When you factor out from the first term, what do you have left? You would have a v squared. From the second one, what would you have left? A w squared. From the third one, what do you have left? A plus u squared. Therefore, that is the answer. You cannot do anything further to that. Let's pick another one. Number 38. Eight u to the sixth v to the third plus 27 u to the third. Okay, equal. What I see here, I see two pieces added together, right? When I look at the special product rule, the only place where you have two pieces added together that can be factored is when you have two cubes added together. So I would think and say, okay, this might be sum of two cubes. So I need to see whether this actually is sum of two cubes. So I'm going to rewrite this first one and the second one in terms of something cube plus something else cube. See if I can do that. Okay, 8 is 2 cube, so 2 would be here. U to the 6 is u squared cube. And v to the third is v cube. So that's how I would deal with the first one. 2u squared v, the whole thing cube. In the second one, I have a 27. 27 is 3 cube, so I write 3, and it's already a cube here. And then u to the third, I write the u. So these two are equal. So clearly you can see this is the sum of 2 cubes. Again, as a reminder, if you have 2 cubes added together, I'm going to write it here, you can factor it. If you have a to the third plus b to the third, that can be written as a plus b times a squared plus ab plus b squared. That's how you factor it. So in this case, what you basically have, this is your a and this is your b. So you can follow this formula, follow this special product rule, and factor this. So again, as you can see here, it factors into 2 parentheses, one smaller and one longer. Okay. Now, where you had a to the third, you write a. Here you have 2u squared v to the third, so you write 2u squared v. Then you have a plus, put a plus. B is this one, 3u. Then in the second part, it says a squared. Now you have to square this. 2u squared v, when you square it, it would be 4u to the fourth, v to the second. Plus a times b, so you multiply the 2 together. 2 times 3 is 6. U squared times the u is u to the third, and then v. And finally plus b squared, so it would be plus 3u squared is 9u squared. So that's what it comes out to when you factor this. So what you have up here, this here is factored into this. Okay, let's look at another one. Number 46, for example. Number 46. It is x times 3h squared plus 1 divided by h minus 1 multiplied by a long line 3h squared minus 3h to the third, 3h to the third minus 5h squared plus x divided by x times x minus 1 times 3h squared plus 1 to the 1/2. Okay, let me put this in parentheses here. Equal. So I'm going to see if I can factor anything here. The only thing that might be factorable is this one here. All right, this is like a trinomial. So I'm going to write everything else as they are. X times 3x squared plus 1, x minus 1 in the denominator, multiplied by. Now here I can factor out an x, and I would get 3x squared minus 5x plus 1 divided by x times x minus 1 times 3x squared plus 1 to the 1/2 power. Now I need to see if there is anything else that can be factored out. This numerator, let's see if this numerator, this part of it as a trinomial, can be factored out. It should factor out two parentheses if possible. One would be 3x here and x here, minus 1 and a minus 1 here. So 3x times minus 1 minus 3x would be minus 4x. So I have minus 5x. So it cannot be really factored out to anything. So however this x and this x can be cancelled. 3x squared plus 1 here. Half of it can be cancelled with this one. So you would have left the power here actually would now be 1/2, not the whole thing. So and that stays in the numerator. So your numerator is now x times 3x squared plus 1 to the 1/2 power times 3x squared minus 5x plus 1. Yeah, and in the denominator you only have this x minus 1 and this x minus 1, so x minus 1 squared. So that's what you would end up with. Again, no matter how complicated the problem seems, if you take it step by step, you really should be able to do it. It's not, and make sure you don't make little mistakes like signs and things like that. Other than that, you should be fine. Then we get to the equations. For example, problem number 52. It's 0.3 m squared minus 2.1 m minus 3.2 equals 0. So in this case, what you're solving for is m. M is what you're solving for. If you adapt the quadratic formula, this is a quadratic equation, by the way, m would be equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So m therefore is equal to minus b is referring to the coefficient of m. So minus b would be 2.1 square root of b squared. B squared is 2.1 squared, which would be 4.41, I think. minus 4 times A, which is 0.3, times C, which is minus 3.2, divided by 2A, that's 2 times 0.3. Therefore, I'm sorry, plus or minus, let me not forget that, plus or minus. M therefore is equal to 2.1 plus or minus square root of 4.41. Okay, now here I have minus 3.2 times 0.3. That would be minus 0.96, and minus 0.96 times 4. That would be 3.84 minus, well, it would be a plus 3.84 divided by 2 times 0.3, that would be 0.6. Therefore, M is equal to 2.1 plus or minus square root of, you add up those two numbers, that would be 5 and 2 and 8.25. I don't know if that would be a square root of 8.25, square root of it would not be a whole number. So basically divided by 0.6. So you have two answers here. You would have two answers. You write it as 2.1 plus square root of 8.25 divided by 0.6, and the other one would be 2.1 minus square root of 8.25 divided by 0.6. Hopefully I did the calculation here correctly when I did this multiplication in these two steps, and if I did, that would basically be your answer. Now this would be an interesting problem, a little bit different. Number 54, it has 2h to the fourth plus h squared equal to 1. Okay, what we can do is bring the 1 to the other side. Therefore you would have 2h to the fourth plus h squared minus 1 equal 0. Okay, this is not a quadratic formula, the quadratic equation. You have the power of 4 here and the power of 2 here. One way I can look at this, I can say that this it would be solved for h squared. In other words, I can use this as a trinomial. Let's see if we can factor it. If I put 2h squared here and h squared here, okay, and I put a plus 1 here and a minus 1 here, this should give me basically the factor for this. So now you have the product of two expression equals 0. So that means either 2h squared minus 1 is equal to 0, or h squared plus 1 is equal to 0. So for each one of them you solve it. So 2h squared minus 1 equals 0. That means 2h squared is equal to 1. That means h squared is equal to 1/2. Further, that means h is, when you take the square root from both sides, h would be equal to plus or minus square root of 1/2. That's one answer. And here, h squared plus 1 equals 0. That means h squared is equal to minus 1. You have to stop here because you cannot take the square root of a negative number. You cannot go like this, take the square root of a negative number. Okay, so you don't get any answer from here. Therefore, the answer to this problem, two answers, it would be these for h. H would be plus or minus square root of 1/2. Okay, let's see if we can do some more problems here. Look at page 64, problem number 58. Problem number 58. It is 3 times 2q plus 1 divided by 4q minus 3 equal 3q plus 1, 2q plus 1. It says solve the equations. Solve these equations, right? When you have two rational expressions equal to each other, what you can do is you multiply one numerator by the other denominator and set it equal to the other denominator multiplied by the other numerator. In other words, what you're going to have here is 3 times 2q plus 1 multiply by 2 by this 2q plus 1 equal, you already have 3q plus 1 multiplied by 4q minus 3. When you multiply things together, this would be 4q squared plus 2q plus another 2q plus 1, close the parentheses. On this side you would have 12q squared minus 9q plus 4q minus 3. So on the left hand side you multiply this 3 by the parentheses, so it would be 12q squared. Well, 2q and 2q is 4q, so it would be plus 12q, and 3 times 1 is plus 3, equal 12q squared, 9q minus 9q plus 4q is minus 5q minus 3. Now the 12q squared on the left hand side and 12q squared on the right hand side would cancel, so I move all the q's to one side. I already have a 12q here. I bring this minus 5 to the left hand side, it would become plus 5q equal. I have this 3, I bring it to the other side, it become minus 3 and minus 3. Therefore I have 17q equal minus 6. Divide both sides by 17. Q therefore is equal to minus 6 divided by 17. That would be the answer to this equation. Sometimes you have to solve a variable in terms of another variable. And problem number 62 is one such problem. Number 62. It says solve, you have equation R equal 2ml divided by b times n plus 1, and it wants you to solve for I. You want to solve for I. So everything else, I'm sorry, instead of L it is I. I was wondering where is the I they are talking about. So this is I. It's not an L. So 2mi divided by b times n plus 1. You want to solve for I. So you treat everything else like constant. So you have a basic equation. You treat everything else like constant except for I. So what I'm going to do is I'm going to give denominator of 1 here and do a cross multiplication, which means this one multiplied by this one equal this one multiplied by this one. So 1 times that is 2mi equal R times this is RB times n plus 1. Now since I'm solving for I have to have I on this side, so I divide everything by 2m. So it would be RB times n plus 1 divided by 2m. That is how you solve for one variable in terms of another variable. Now into inequalities. How you solve inequalities. Let's look at problem number 64. Problem number 64. You have minus 2 less than or equal to 3x plus 1 less than or equal to 7. So basically what you have here, you have two inequalities written as one. I'm gonna have it separated right now. You have 3x plus 1 less than or equal to 7, and you also have, let me put it on the side. You have 3x plus 1 less than or equal to 7, and you also have 3x plus 1 greater than or equal to minus 2. So you solve each one of them independently. So what do you do here? You can take one to the other side, or you can say you subtract 1 from both sides. So 3x would be less than or equal to 6. Now you divide both sides by the coefficient of x, which is 3. Therefore, x would be less than or equal to 2. That's one answer. And here, take 1 to the other side, it become minus 1, and 3x would be greater than or equal to minus 3. Divide by 3, x would be greater than or equal to minus 1. So that's the answer, right? And the way you write it in the interval form, you write it as 2 with the bracket, since it is equal to, toward infinity with parentheses, and here greater than equal to minus greater than equal to, I'm sorry, I made a mistake in the first one, so let's do this one more time. It says x less than or equal to, x less than or equal to. That means it goes from minus infinity to 2 with a bracket, right? It is less than 2, so it's to the left of 2. And here is x greater than or equal to minus 1, so you start at the minus 1 and you go toward infinity. That's the answer. So this or this, you put a u in the middle of it. That would be your answer. Okay. Now, if your inequality is a quadratic form, such as 72, a quadratic form, you solve it a little bit differently. So you have x squared plus x minus 12 less than or equal to 0, right? So here what you're going to do, you're going to factor your quadratic part, set it equal to less than or equal to 0. So here would be x, here would be x, minus 12. How about if we put minus, since it is the middle, it put a minus 3 and a plus 4. Okay? And the next thing is, you're going to find the roots of this inequality. That means what makes the left-hand side 0? What makes the left-hand side equal to 0? And you're going to put that roots on the number line. So here's a plus infinity going in this direction, minus infinity going to this direction. Here is 0, right? So the roots means you set x plus 4 equals 0, therefore x is equal to what? Minus 4. So that's the root of x plus 4. The root of x plus 4, x is minus 4. If this is 0, let's say minus 4 is here. So when x is minus 4, x plus 4 would be 0. Then you ask yourself, what if x is greater than minus 4, such as 0? What would you have? You have 0 plus 4. It would be positive. So to the right of minus 4, everything would be positive. To the left, everything would be negative. You do the same thing with the other one, x minus 3. x minus 3, what is the root of that? That means x minus 3 equals 0. That means x is equal to 3. So let's say here is 3. So right at 3 would be 0. Then you ask yourself, what if x is less than 3, such as 0? Would it be positive or negative? Well, x is 0, it would be 0 minus 3, it would be negative. So to the left, everything would be negative. To the right, everything would be positive. Finally, the product, which is x plus 4 times x minus 3. x plus 4 times x minus 3. What about their product, right? Well, first of all, if one of them is 0, such as x plus 4, when x plus 4 is 0, their product would also be 0. If x minus 3 is 0, their product would also be 0. So right in front of that, you would have 0 and 0. Then in between minus 4 and 3, one is positive, x plus 4 is positive, x minus 3 is negative. Positive times negative would be negative. And to the right, positive times positive would be positive. And to the left, negative times negative would also be positive. Go on like that. Then we notice that what we want is we want the product to be negative or 0. Negative or 0. When would it be negative or 0? This is where it would be negative or 0. When x is minus 4, or x is 3, and anything in between. So the answer here for you, would be bracket minus 4, comma 3 bracket. That means between those, the interval between those two would satisfy this inequality. So that is how you do a quadratic inequality. Another topic has to do with absolute value. With absolute value. What we need to know is, in the absolute value, what we need to know is that absolute value of A is equal to A if A is greater than or equal to 0, and is equal to minus A if A is less than 0, if A is negative. Okay? So for example, absolute value of 5, since 5 is positive, would be equal to 5 itself. But absolute value of minus 5, since A is negative, it would be negative of negative 5, which means it's equal to 5. Keeping this rule in mind, we solve problems like problem number 70. Problem number 70. In the review part, it says absolute value of square root of 3 minus 4 plus absolute value of 4 minus 2 square root of 3. Evaluate this expression. Okay? So what I'm going to look at is inside this absolute value, square root of 3 minus 4. Would that be a positive or negative number? Square root of 3 is about 1.7. Minus 4, it would give you a negative number, negative 2.3. Therefore, since we are looking at the absolute value of a negative number, right? Absolute value of negative number, it would be a negative of that. So it's a negative of square root of 3 minus 4. Now here, 4 minus 2 square root of 3. Again, 2 square root of 3. Square root of 3 is 1.7 approximately. Minus 2 multiplied by that, it would be minus 3.4. 4 minus 3.4, it would be a positive number. So it would be a plus 4 minus 2 square root of 3. Now we combine. Let me apply this negative here. So negative square root of 3 plus 4 minus 2 square root of 3 equal. So I have a 4 and a 4, that give me 8. I have minus 2 square root of 3 and minus 1 square root of 3, that give me minus 3 square root of 3. So that is the answer. Now, going to absolute value combined with inequalities. Absolute value combined with inequalities. Let me say what I mean here. If you have absolute value of x less than or equal to some value a, right? If it is absolute value of x can be just one thing or it can be a whole expression. So, and a is a constant. So if absolute value of x is less than or equal to a, that means x is less than or equal to a itself, or x is greater than or equal to minus a. Okay, so let's have an example. Absolute value of x is less than or equal to 5. There I'm saying that x therefore would be less than or equal to 5, or x would be greater than or equal to minus 5. Right? So let's pick a number here and try and see what happened. Something less than or equal to 5, 0, right? Less than or equal to 5 is 0. So going back here, x is equal to 0. Absolute value of 0, is that less than or equal to 5? Absolute value of is 0. 0 is less than or equal to 5. So I'm okay at this end. Now here, I said x has to be greater than or equal to minus 5. X greater than or equal to minus 5. For example, x equal something greater than minus 5, minus 3. Minus 3. Then I go ahead and plug in for x3. So absolute value of minus 3. Is that less than or equal to 5? Absolute value of negative 3 is negative of negative 3. Is that less than or equal to 5? Negative 3 is 3. And that is less than or equal to 5. Okay? Therefore, this relationship is correct. If you have absolute value of x or any expression less than or equal to constant, that means that expression or that x is less than or equal to a or greater than or equal to minus a. What if absolute value of x is greater than or equal to some a? If absolute value of x is greater than or equal to a, that means either x is greater than or equal to a, or x is less than or equal to minus a. Again, as an example, absolute value of x is greater than or equal to 5. That means what I'm saying is x has to be greater than or equal to 5, or x has to be less than or equal to minus 5. Of course, if x is greater than or equal to 5, like 10, then absolute value of 10 is greater than or equal to 5, because absolute value of 10 is 10. 10 is greater than or equal to 5. That takes care of this. On the other side, if x is less than or equal to minus 5, so absolute value of something less than minus 5, minus 7, right? Absolute value of minus 7, is that greater than or equal to 5? The answer is absolute value of minus 7 is minus 7. Is that greater than or equal to 5? Minus 7 is what? 7. 7 is greater than or equal to 5. So that is true. So this relationship is what you need to remember. Okay? So here is what we have. For example, we have number 74. (2x minus 3, less than 5. Okay? Absolute value of something is less than a constant 5. What do? You say, therefore, the 2x minus 3 is less than 5, or the 2x minus 3 is greater than minus 5. Right? Isn't that what we had on previous pages? When it is less than, x less than or equal to a, or greater than equal minus a. Less than and greater than negative, right? So less than and greater than negative 1. So you solve this one, 2x less than, take minus 3 to the other side and would make it 8. Therefore, x is less than 4. And here, 2x minus 3 equal greater than minus 5. So 2x greater than minus 2. X greater than minus 1. So in terms of interval, x has to be less than 4. So from minus infinity to 4, not including the 4, therefore it would be parentheses on both sides. And x greater than minus 1, so it's from minus 1 to infinity. So anything between minus 1 and infinity, not including minus 1 itself, would satisfy this equation. Well, let me do one problem also. Let me do one problem, one word problem from section 1.8. Section 1.8, problem number 72. It says motion of a model racket. A model racket is launched vertically upward so that the height is measured in feet t seconds after launch is given by, so the height as a function of t is given by minus 16 t squared plus 384 t plus 4. Find the times when the rocket is at the height of 1,284. When would it reach, at how many seconds after its launch it would reach the height of 1,284. So what you want is, you want this to be equal to 1,284, because this is the height, right? So you would have minus 16 t squared plus 384 t plus 4. Take this to the other side, minus 1,284 equal 0. So minus 16 t squared plus 384 t minus 1,280 equal 0. So what you have here is a quadratic equation. Solve for t. You can solve for t either by factoring or using the formula. And you're going to end up with two answers for t. Right? So that would tell you the 2 points that the rocket reaches the height of 1,284. How long is the rocket in flight? How long is the rocket in flight? The rocket goes up and then comes down and hit the ground, right? So what you're measuring is where the height comes back and be 0 again. The rocket goes up and hit the ground again, right? It hit the ground right here. So the height is again minus 16. The height is minus 16 t squared plus 384 t plus 4. You set this equal to 0. Now solve for t. Solve for t. You're going to come up with two values for t, right? And I think one of them would end up being negative. The one which is positive is what you're looking for. That means after, so this is on t second after it was launched. Here someplace about, I don't know, 8 seconds or so I don't know exactly what it would be. So it goes up and hang up and then come down. 8 seconds later, it will hit the ground again. You can solve that yourself. Well, I think that covers basically everything in this chapter, and I hope that helps. In addition to the modules and other video exercises that we have, and media gallery, which comes with your ebook, and I think they all should help pretty much.